Okay, Assalamualaikum warahmatullahi wabarakatuh and good day. So do you hear my voice?
Yes, doctor.
Is it clear or not? Because I didn't use earphone.
Yes, it is crystal clear.
Okay, good. All right. So basically for today class, I will summarize chapter 2 and will not revise just to highlight chapter 3. Okay. So before I start for today lecture, okay, so last class or last week, okay, you learn about confidence interval, okay, but we only touch until two population proportion, okay. So you have done for mu. So this mu you have one mu, you have mu d, you have mu1 minus mu2 or mu2 minus mu1. Okay, so this is first parameter. And then you have pi proportion where you have one population and then you have two population. Okay, or pi 2 minus pi 1. Okay, it depends on question. Okay, which one they ask you first, and if they didn't mention which one first, you try look which info they mention first. Okay, but sometimes if they didn't mention in the question, you can have both lah. Okay, pi 1 minus pi 2 or pi 2 minus pi 1 or mu1 minus mu2 or mu2 minus mu1. Okay, all right. So from this two parameters, you can see lah, you have Z table, T table, okay? But now you will have another two parameter, which is first is standard deviation, okay? And one population variance or one population standard deviation. That means you will have sigma square for variance or sigma only, okay? When you want to find confidence interval for this one, you will use another table called chi-square, okay? And then you have two population variances. And we didn't have two population standard deviation. We don't have, okay? It's a ratio tau, it's not a difference. So you can see that if mean we have difference, proportion we have difference, but for variance we have ratio. Either sigma 1 square divided by sigma 2 square or sigma 2 square divided by sigma 1 square. Alright, it depends on question as well lah. Okay, which one come first? Okay, but you must clear this one. Alright, so here you will use F table. Okay, but the objective is still similar. You want to find confidence interval. Okay, either you have two-sided or you want to have upper bound or lower bound. Okay, so I go through the one population variance and one population standard deviation because it's quite different from mu and proportion. Okay, especially on the table though. Okay, the curve or the shape of the distribution though is different. Okay, it's not approximately normal, but it's skewed to the right. Okay, if you can see the screen here, so this is for one population variance and one population standard deviation. So this is the formula for variance. This one you just square the formula variance, you get the standard deviation. But important here, when you use chi-square table, you have this distribution. So you can see this is skewed to the right. So at the right side, chi-square alpha over 2. Okay, but here, the left side here, it will be 1 minus alpha divided by 2. Okay, if you have two-sided. Okay, because for chi-square and F table, here start with 0 until infinity. Okay, we don't have any negative value for this chi-square table and F table actually. Okay, so the formula is given. Okay, no need to memorize, but you should know where to find the chi-square and then what is the value for left side and right side. Okay, so actually if you go through this example, you can see lah, you can see that the left side value ni should be smaller than the right side, okay, because you have from 0 until infinity here. Okay. All right, so that's the most important I want you to understand. Okay, that's different things, but the objective is this similar. You need to find the confidence interval. You need to find A and B, and then this is how to interpret. And then here important, when you calculate for variance, you don't have unit. Okay, and then if you look here, we don't have unit. But if you find standard deviation, mean or proportion, you will have unit like this. Okay, is that clear? Is everyone clear?
Yes, madam.
Okay, good. So this one for upper bound and lower bound. Okay, so here as well, don't confuse, okay? If they ask you upper bound, that's when you find the right one, okay? This side, that's when you calculate this value, okay? So here, it will cover from 0 until this value. This is what we want, okay? But for chi-square, for the lower bound, you calculate here, okay, this one, okay, until infinity, okay. So in this case, the alpha should not divide by 2 lah. Okay, you can see the formula ni, the alpha should not divide by 2, and then look, you can see ni the difference. For lower bound, okay, what is the value here and what is the value here? Okay, you can see from this formula as well. This is for lower bound, this is for upper bound. But alpha should not divide by 2. Okay, and I think I mentioned also about estimation error, isn't it, before this? Okay, so if you look at the first, at the early of my lecture for estimation error ni, okay, at this part, the concept of estimation error is very similar. Okay, you can see that from the very general knowledge, here, okay, you can see that the estimation error or the margin of error, okay, it will be this part, okay. Actually, you have from A and B, okay. So how to find inside here? Actually, you can have from width, isn't it? Width equal to B minus A, and then you have how many area? 2. So you can find the estimation error too for one single side. Okay, that is example. Okay, I think if you look the quiz question, okay, you have that kind of thing as well, isn't it? Okay, but you need to understand the concept too. Okay, estimation error, and then you must understand as well about a parameter. Okay, estimation point. I mentioned that to you last class. Okay, in this case, this is your parameter. Okay, the estimation point for this one actually S square because it's a sample. This is for parameter. So this one will be S. Okay, so that one is for one population variance and one population standard deviation. Okay, so now is for ratio of 2 population variances. So instead of one population variance, we have 2 population variance. And the only formula we have, this one. Okay, at this part, student also sometimes confused. Okay, so you look which one divide by which one. So in this case, oh, sorry. So in this case, variance 1 divide by variance 2. So here, sample variance 1 divide by sample variance 2. So similar for this one. Okay, can you see? You see that, isn't it? So now, you look this one. This is F table. This is F table as well. So you can see the F table is skewed to the right as well. So the value will be from 0 until infinity. Okay, so because this is two-side confidence interval, so alpha should be divided by 2 lah. But you can see here, the right side is alpha over 2. Here 1 minus alpha over 2. Okay, the concept is similar. Now look here, the formula. So if you look the formula ni, 1 minus alpha over 2, the left side. But here, you can see that new 2, new 1. New 2, new 1. It's not new 1, new 2. It's new 2, new 1. Okay. And then, the left side here ni, it will become like this. 1 over f alpha divided by 2. This one become new 1, new 2. The other way around. But this one kekal. Okay, this one still new 2, new 1. Okay. That's very important because students always confused about that. How to get the value. And then if you look table, F table, if you have the table with you, it will be page chi-square is page 38, 39, but F you will have page 40, 41 until 40, until 55. Okay, so you need to look first what is the alpha value, and then if you look table, okay, the F table, you will have new 1, new 2. Okay, you will have like this, and then here alpha lah. Let's say 0.05. You need to find first what is your alpha from the statistical table. And then in order to you read the table ni, so which one come first here is your new one. Okay, for example here, they mention new 2, but this one come first, isn't it? So at the table, you should read as a new 1. And then new 1 is a new 2. Okay, so again, I mentioned in the table here, you should read which one come first from the formula as a new one. Okay, new one is this one dia bukan V, dia memang new. Okay, kalau dalam maths punya notation, dia new, dia panggil new. Alright, this is the explanation lah what I've done just now. Okay, and then you can try check here. Do you understand or not? When you look at the table, this one actually new 2, new 1. But then when you read the table, this one become new 1, new 2. Okay, this one very important. All right. So you can try example and look. Okay, and again, this is variance. So no need to have a unit. Okay, and then from the table too, you can see that the left side should be smaller than the right side. Okay, so this is for one side, one-sided for lower bound and upper bound. So similar lah, the concept is similar with chi-square. The alpha should not divide by 2. Okay, and how to read the table tu pun similar. Okay, alright. Any question for chapter 2? So chapter 2 basically your objective to find a confidence interval for 4 parameter. What is the parameter? Mu, proportion, variance, standard deviation. Okay, so here you have a few things lah. Here you have 2 things. Here you have 2 things as well. All right, so the concept is similar. Clear or not?
Yes, madam.
Yes, madam.
So good. So now your test will be from chapter 1, chapter 2, and then until chapter 3. Okay, chapter 3 until 3.2. So I will go through chapter 3 ni. So basically if I said it until chapter 3.2, for sure lah 3.2 tu ada. Okay. So here I want to, I know you watch the video, so very good. So I just want to highlight what step important and what should you know. Okay, so I hope that in the test letter, you can answer the chapter 3 question. Because in final, you cannot accurately say 3.2 is in the final, isn't it? Because it can be any question. But here in test, we mentioned to you from chapter 1 until chapter 3, 3.2. So is there any 3.3, 3.4 or 3.7? No, not yet, isn't it? So confirm 3.2, you will have a question on that. All right. Okay, so chapter 3 is about hypothesis testing. So actually it's a continuity from the confidence interval. Whatever situation, condition that you learn in chapter 2, you will bring that into chapter 3. Okay, for example, mean. Okay, when we do hypothesis testing for mean, the condition is still similar. For example, population variance known or unknown, sample size greater than 30 or not. All that condition is similar with chapter 2. But chapter 2, we just find confidence interval. Chapter 3, we do the hypothesis testing. That means we want to see either the claim is significant or not. Usually, you will do this when you do the PSM lah. All right, your final year project too, you need to do the analysis, and then based on this hypothesis testing, is it support your experiment or not? Something like that. Okay, so in this chapter 3, we have this expected outcome. Okay, you can see that we still focus on mean, two population mean, and then we have independent, dependent, and then we have proportion, and then we have variance. Okay, and then for chapter 3, we have three methods. We have traditional method, we have p-value method, we have confidence interval method. Okay, confidence interval method ni you learn in chapter 2, but based on the confidence interval answer tu, how do you know hypothesis testing is reject or not reject? Okay, so this is the contents. Okay, again I mentioned to you, your test is until 3.2. Okay, so 3.2 ni confirm masuk lah. Okay, because 3.1 is just introduction of hypothesis testing. You need to know how to do the hypothesis testing. Okay, 3.1. But 3.2 show you how to do the how you do the hypothesis testing. Right. So again, this is very detailed content lah. Okay, one by one. But today I just want to cover until 3.2. So basically here, all this, all right, introduction. I know that you have read this one, but I want to highlight at this part is not this one, this one. This we call hypothesized value. Okay, this value always given in the exam or in the question. Okay, so in this case, this is a general term lah. Theta, theta naught. So theta ni can be what? Can be mu, can be pi, can be variance, can be standard deviation. But since we until 3.2, we only have one mean at the moment. Okay. So we have null hypothesis, we have alternative hypothesis. And then we have two tail, we have right tail, we have left tail. How do you know this one? Two tail when you have this one, not equal. Right tail when you have greater than. Left tail when you have left side. Okay, so this one will follow the area of rejection region. This is how do you know is greater than, is it right tail, left tail, or not equal? So this is the common phrase that we use in the sentence. And then you must understand lah, if we say it's not more than, so it will be less than equal. So when less than equal, they are the equal sign, isn't it? So equal sign should be at H now. That's the tips as well. When you transform, okay, from the sentence, you transform, you have equal sign. Whatever you have equal sign, it will be at H now. But when you transform the sentence, you didn't have any equal sign, it will be at H1. Okay. So I believe you go through the example there. Okay, so basically at step 1, this one lah. Okay, you write your hypothesis testing. And then step 2, you will have the test statistic. So this test statistic, it depends on your parameter. So that's why I said at this step 2, the condition or the rule that you learn in chapter 2, you will bring this here. That means Z-test, you will use Z-test when you have, if for mean, when you have what? Population variance known. Okay, sample size greater than 30, you will use Z test. Okay, but for F test, you will have when you have ratio of 2 variance. Okay, so that's the concept. Okay, but we focus on one population mean first. So this one, rejection region and acceptance region, it depends on your step 1. Okay, your H0 or H1 too. Okay, your H1, if not equal, you will have 2 tail. So this is the rejection region. The dark side considered is the rejection region, but the white side is considered a acceptance region. How do you know rejection region or acceptance region? It depends on your significant value. This one, alpha. What is alpha? Here. Okay. I will go through one example, okay, later. And then critical value, you will get it from the table. Okay. So step 2, if you use Z test, you will refer Z table. If step 2, you use T test, you will use T table. Okay. Alpha should not divide by 2 or not. It depends on your step 1. Okay. And then important here, how do you know you should reject H0 or not? Okay. So how do you know? You look first your area. Okay. If the statistical value is at the rejection region, so you reject H0. If the statistical value is at the acceptance region, you accept H0. Okay, I'll show you by one example. Okay, don't worry. So this is what I mentioned just now. Okay, this is two tail. Why you say it's two tail? Because you have this one not equal. So you have left and side. So alpha should be divided by 2. So when alpha divided by 2, look table. What is the value? So in this case, Z table, negative 1.96, 1.96. Okay. So step 2, let's say you have Z test equal with 2.4. So look, 2.4, where is it? Is it at the dark side or at the white side? So 2.4 positive, this is 1.96, is here, isn't it? So at the dark side. So we will reject H0. Okay? So here right tail, how do you know it's a right tail? Because of this. And the area will be here. Alpha should not divide by 2. Okay, because you have one side tail only. And then left tail, because you have less than, and this is the area, alpha should not divide by 2 as well. And in this case, because we use Z table, so the left side value will be negative lah. Okay, but when you have one population variance, one population standard deviation, or 2 ratio variance, you will have chi-square and F kan distribution. So you will not have negative value. Okay. So this is the step. Okay. First step, write your hypothesis testing. For your test, this one is mu. 1 mu only. This will be the value. The value will be given in the exam. And then, because this is mu, you have a few conditions, isn't it? Population variance known or population variance unknown. So, if known, you straight away use Z test. The formula is given as well in your statistical table, okay, at the front page too. Not front page, 5 I think, 5 ke 8? Yeah, 5, okay. At 5, page 5 too. The left side is confidence interval formula. The right side is hypothesis testing formula. Okay. So when the population variance is unknown, you need to check the sample size, isn't it? Greater than 30 or less than 30. Okay. So less than 30, you will use T test. But this one, you will use Z test as well. But instead of sigma, you will use S over square root n. This one x bar minus mu. This one given lah, no need to memorize. Okay, but I just want to show you the difference. Here we use S because we didn't know the value sigma. But here we will have the same thing, but instead of S here we use sigma because we know the value. Okay, So that is step number 2. Step number 3, find the critical value. So this is what I mentioned to you. If we use Z-test, here you will use Z-table. Okay, and then look, is it one tail, right tail, left tail, or is it two tail? Okay, because you want to check here, is it alpha divided by 2 or not? All right, and then step 4, make decision. Okay, usually at step 4 ni, I like lah student do this kind of graphical and then look where's the area and then show how you say it's reject and then draw conclusion. So at conclusion, you must say at alpha 0.05, we can conclude what is it. Okay, so I'll show you by one example. This one I don't want to highlight because first you must understand, you must understand the first step tu. Okay, claim ni actually whatever they mention in question, we consider is a claim. Okay, so this is about hypothesis testing for one population mean. Okay, just now what we learned in previous slide ni is a general thing. Okay, concept which you will use. But here specific for one population mean. So you can see lah. This is what we have when we two tail, right tail, left tail. Mu naught ni is a value. Okay, this is a value. Then you can see the condition is just similar. This one is similar from chapter 2, but the different, this one lah, you have formula test statistic. Okay. So, okay, we go through this example, okay? I know that maybe you have, maybe I don't want to use this, maybe I use exercise lah, I use exercise question number 5. Can we try that one? Are you with me or not?
Yes.
Okay. Alright, good. Alright, so here, boleh ke kalau I buka lagi satu? Boleh kan? I nak buka supaya kiri kanan tu ada. So, I nampak. Sekejap ya. I mungkin tak berapa canggih compare you all punya lecturer lain. Tapi tak apalah, I cuba, okay? Alright, so because I want to look the question and to write down here, okay? So if you look the question here, a rocket missed its target. So you can see that we have rocket and then di rocket ada target dia kat sini. Okay, contoh dia nak target kat sini kan? Instead of sini, dia miss kat sini. Nampak tak? Target kita sini. Tapi dia miss kat sini. Okay. So a rocket missed its target by an average of 0.88 kilometer. So here, the keyword is average. So average, it can be mu, it can be x bar, isn't it? Okay, with a standard deviation of 0.04 km. So here keyword also standard deviation. Okay, however, here you must understand average, is it mu or x bar? Standard deviation, is it sigma or s? That's very important in statistics. So I mentioned to you, this is given in the first sentence and didn't mention how many rocket, a rocket, but didn't mention how many trial this rocket and then get average 0.88. Okay, dia tak bagi tahu pun berapa banyak trial diguna untuk dapat average ni. So, basically, the first sentence show you mu is equal 0.88 km and then you have sigma equal to 0.04 km. Okay, so this is how do you know, is it sigma or is it s? Is it mu or is it x bar? Okay, how do you know it's a population or how do you know it's a sample lah? Okay, so that's how. And then the second sentence, a new design rocket is supposed to increase accuracy. Alright, so kita ada design rocket baru, mungkin dia gelembung macam ni. So kita nak try shoot sini juga. And then this one kita consider increase accuracy. So, bila dia kata increase accuracy, is it greater than or less than? Anyone?
Greater than.
Are you sure? You need to understand the experiment, or you need to understand the situation as well tau. In this case, kita ada target kat sini. Okay? And then roket lama ni dia selalu miss target ke laut. Kita nak ke gunung, dia ke laut. So bila ke laut, maksudnya dia ada beza sini banyak, betul tak? Tapi kalau kita kata roket baru, increase accuracy, dia akan apa? Dia akan kecilkan beza ataupun akan besarkan beza?
Oh, makin kecil lah, doktor.
Ya. Okay, dalam kes ni, increase accuracy dia akan jadi less than. Kat situ student selalu je akan confused ataupun tak berapa faham. Sebab tu I ambil jawab soalan nombor 5 ni. Sebab soalan lain dia macam straightforward. You tahu. Maksudnya kalau smaller memang less than. Tapi dalam kes ni, you should understand the situation. Dan benda ni juga akan berlaku bila you measure about quality. Sebab quality, you akan kata, kalau kita measure quality, kita akan guna variance kan? Ataupun standard deviation. Okay, maksudnya kalau variance, kalau quality tu bagus, variance dia kecil. So dia akan less than. So sama, cuma dalam kes ni kita guna increase accuracy dengan decrease accuracy. And then dia punya situation sebab kita nak ada target and then target tu miss lah. Okay, so dalam kes ni increase accuracy adalah less than. Okay, I bagi tahu tu dulu. And then a random sample of 30 location were equipped with this new rocket. So bila dia kata random sample of 30 location, that means you ada n equal to 30. Okay. This 30 rocket missed by distance with a mean of. So you can see a mean is average as well, 0.6 km, 0.76 km. And this one, how you get this one? From 30 rocket, isn't it? So that's why you will have x bar equal to 0.76 km. And then a standard deviation of 0.04. So this one S as well, 0.04. Okay, because you know that this value, how it's come? It's come from this 30 rocket. So that's why it's a sample. Okay, and then the question asks you, does the new design rocket able to increase the accuracy at 0.1% significant level? Here important as well, 0.1% significant level. Okay, some student also cannot change this value. It's not 0.1, it will be what? What is the value for this one? Anyone? What is the value there? This one? Anyone? Anyone answer in the chat?
0.001.
Yes, this is the value, okay? Oh, sorry. So this one, it will give you 1, 2. So 0.001. Okay, to the left. Because you have percentage ni. Percentage ni ada 2 kosong. So 2 tempat ke kiri, you dapat 0.01. So here, your alpha is 0.01. Okay? So, dalam chapter 2, dalam chapter 3 ni, chapter 3 ni, dia tak akan cakap confident interval. Maksudnya macam nak, setengah student dia akan tanya, macam mana dia nak tahu dia confident interval ataupun hypothesis testing. So kalau dia confident interval, dia memang akan cakap, find confident interval, 98% confident interval, bla 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 bla. Tapi kalau dalam hypothesis testing, dia akan, ayat dia lebih kurang macam ni je lah. Okay, dia tak ada mention pun pasal confident interval. Okay, so that's how do you know it's a confident interval or it's a hypothesis testing. So this is hypothesis testing. So how many steps you have? Kalau traditional, kita ada 5 step. So step number 1, you kena tulis H0 and H1. So dekat sini, at the moment, you cuma belajar sampai one population mu. So, for sure kat sini ada mu je. Okay? Tapi, bila you dah complete one chapter, chapter 3, you akan tanya, macam mana kita nak tahu dia mu? Macam mana kita nak tahu dia variance? Macam mana kita nak tahu dia proportion? So, tengok balik soalan. So, when you see the question, we are talking about missed target by average. And then, we have standard deviation, but then this average can measure the accuracy as well. So that's why in this case, we have mu. Okay, sometimes in the question, they ask about quality. So when they ask about quality, we cannot use average to measure the quality of certain product. We need to use variance or standard deviation. Siapa baru masuk tu? Dia all terkeluar. Jom. Tak apa, I rasa kadang-kadang ada yang terkeluar ni. Okay. Alright. Tapi untuk sampai test, ini je jawapan nombor pertama. Bukanlah, ni tak habis lagi lah jawapan dia. Tapi maksudnya mu tu, mu. You tak akan confuse. Nak proportion ke, nak variance ke, you tak akan confuse. Dia mesti nak mean saja. Okay. So now, the question asks you, does the new design rocket able to increase the accuracy? So in this case, when we say increase accuracy, that's mean it should be smaller than, okay, the mu ni. This mu should be smaller. Okay. I mean, the new rocket punya mu should be smaller than this one. Okay, so smaller ni, ada tak equal sign? Ada tak equal sign? Guys, do you have equal sign here?
No.
So if no, where should we put? H0 or H1?
H1.
Yes, yes, correct. H1. Okay, less than. Less than what? This one. Because you know, this is the mu value. So 0.88. And this is the claim. Okay, how do you know it's a claim? You get it from the question. Okay, so this is the claim. So here less than, the other side will be greater than 0.88. Okay, so that is first step. So from the first step, can you see that? Is it two tail, right tail or left tail?
Left tail.
Yes, left tail. Very good. Because you can see this one, okay? So, kalau I nak draw, dia akan jadi sebelah kiri sini. Okay? So, alpha ni, kalau dia sebelah kiri, should I divide by 2 or not?
No.
No. Okay? Very good. So, that is step number 1. Now, step number 2. Test statistic. Okay, so test statistic, we have mu. So again, mu, when we have mu, either z-test or t-test. Okay, so now we look. Do we know the sigma value? Is the population variance known? Is it the population variance known or unknown?
Known.
Known, because we know this one. Okay, so when known, we use z-test. Okay, z-test, the formula will be x bar minus mu over sigma over square root n. We have sigma here. Formula tak payah hafal ya, ni saya memang dah tahu. So you guna formula table, jangan terbalik pula. So x bar, you have this value. Mu, you ada value dia kat sini. Okay. Sigma, you have this value. And you have this value. So bila you substitute the value, so you will have 0.76 minus mu 0.88 divide by 0.04 square root 30. Can anyone calculate for me? Kau you all tak ada calculator depan you? Berapa jawapan? Anyone? Anyone? Berapa sah?
Negative 16.43.
Yes, 4 decimal places. Okay, dear. 4318.
17.
1 yes, 17. Thank you. 17. Okay. Remember, in statistic, 4 decimal places everywhere. Okay. So you can see this is your value. Okay, this is what you have. Okay. So now step number 3. Step number 3, you use Z-test, isn't it? So step number 3 is critical value. So critical value, you get it from statistical table. So you know that step 2, you use Z-test. So here you use Z-table. So you know that this is 1 tail, it's not 2 tail. So alpha should not divide by 2. So 0.01. Okay, this one I salah ni. It should be 0, 1. Okay. So here, and then it's a left tail, isn't it? It's a left tail, isn't it? Here. So it should be negative or positive value?
Negative.
Yes, negative. So when you look table, statistical table, page, let me see. Hmm, 34, isn't it? So, sorry, not 34, 36. So 0.01, 3.0902. Is it correct? 3. Mana? Betul lah, 09. 3.0902. But because it's left side, negative value. Can you see that? Can you see that or not?
Yes, Doctor.
So now step number 4. So step number 4, decision. So decision, we have 2 ways. So I will consider both answer, but if you didn't clearly show me the graphical too, so it will be sometimes cannot consider lah. Okay, but you know this is a left tail. Okay, I'll show you both way lah. So when you use graphical, you know that this is Z distribution, symmetric. You know that you have left-sided. So this value you get here is negative 3.0902. Okay. Now look your Z-test. What is the value? Negative 16.4317. Okay, I just put here Z-test negative 16.4317. So if you look this value, is it at the dark side or is it at the bright side?
Dark.
Dark.
Dark. Okay, this value is here. So when it's at the dark side, what should you do? Reject H now. All right. So this is first. I mean, some student can see this clearly lah. Okay, but you must show me this one. Reject H now. This value, where is it? Okay. Okay. Some of you can do also by writing. Okay. So this is how do you do? Reject H now since Z test. What is it? Negative 16.4317 less than Z table. You boleh juga letak Z 0.01, okay. 0.001 which is negative 3.0902. Macam tu. You dah mention dah, reject H now since this value is less than this value. Okay, because you can see even from figure you can see lah at the left side. Okay, so in this case for left side, some question we have right side. So this one will be different. But the concept here, when you look the step 2 value at the dark side, reject H now. Okay, is it clear?
Clear, madam.
Okay, so now your answer or your decision is reject H now. Okay, so now step number 5, conclusion. Okay, when you do step number 4, in order for you to do the step number 5, I don't want you to memorize the standard sentence ke apa. No, I don't want. But you must understand the concept, okay? So here, reject H now. So if you look step number 1 back, this is your step number 1 back, you reject H now, that's mean you didn't get this one lah. This is your answer, isn't it? This is what you get. And in here, actually, what does it mean? It's increase the accuracy, isn't it? Or we consider it's a claim, this one. Okay? So when you do the when you do the conclusion, first important, you should mention about the alpha. At alpha 0.001, we can conclude that, okay, you can take back here. The new design rocket able to increase the accuracy. You ambil ayat ni balik. Sebab this is ayat claim. Ayat, ayat at step 1 yang H1. Right? And then kita do not reject pun this one. So bila kita tak reject this one, this is what we have. So what is the conclusion? The new design rocket able to increase the accuracy. Okay, but some student can consider also at alpha 0.001, we have support evidence. We have sufficient evidence to support the claim. Okay, because this is the claim. Okay, tapi sometimes the claim can be rejected as well. Okay, so that's why I said step number 5 ni, you must understand the concept. No need to memorize. Is it sufficient evidence? Is it insufficient evidence or not? And so on. Okay, but you can see from the first step too, if you understand what is it, and then at step number 4, look, do you reject or do not reject? So dalam case ni, you reject H now. Alright, you accept H1. So H1 tu apa maksud dia tadi? Increase accuracy. So conclude balik kat sini. We have sufficient evidence to support the claim where the new design rocket able to increase the accuracy. Tapi alpha ni memang kena tulis. Okay? Why alpha kena tulis? Any idea? Do you have any idea or do you have any opinion why you must write the alpha value? Anyone? Dia macam juga you buat eksperimen ataupun you buat project juga kan? Maksudnya kalau by alpha 0.01 you reject H now. Tapi maybe bila I tukar nilai value alpha ni, sometimes your decision is not similar because this value. When I change alpha, let's say 0.1, this one will be different as well, isn't it? So when it's different, sometimes your decision here will be different. That's why when you conclude, you must have alpha here. So similar when you do your PSM later in the future, you must mention what is your significant level. So then maybe other people, when they do their project, which is similar with you, when they use different alpha, they will have different decision, okay, or different finding. Okay, all right. So any question? Do you have any question, guys?
No.
No, okay, so nearly coming is your submission for assignment, isn't it? 9 April. Okay, so only ketua je lah submit. Seorang je submit, jangan semua, okay? I rasa I dah letak dekat kalam, alright? And then based on quiz 2 last time, when we do the quiz for all applied stats student, which is 1,000 plus, and then actually at the same time, the numerical student as well have their test at that night. So the column seem like not work nicely, right? So some of the lecturer move to Google Classroom. Okay, so I want also to take that opportunity to consider Google Classroom for your test. Okay, I will do in the column as well, but the submission I think better in Google Classroom. Are you with me or not?
Yes, Doctor.
Okay, kan?
Okay.
So then I will send the code, Google Classroom code. All right, then you will apa ni? Join lah. Okay. Then for test, I think we use GC lah. Okay, GC. But others maybe I will, but I still put both lah. Okay. Assignment we just use column lah. Okay, because it's not really urgent. Not urgent lah. It's not really all of you will submit at the same time, because the column we can see that it will be a problem when all students do or use the same at the same time. Okay, still not very good yet lah, not strong enough yet. Okay, so I think that's all. Okay, so again, if you have any question, any problem, please let me know, then I understand you more better. And then, yeah, I will try my best to return the quiz 1 and quiz 2. But if cannot, or if I'm struggling to do that before your test, I will give the answer scheme so that you can check yours, or you can compare lah whatever you have submit to me, which one is correct or which one is not. Okay? Is it clear? Is it clear? Okay. So next week, we will have a sync class on Wednesday before test on the Thursday. Okay. So that sync class, I will not highlight about the lecture for next week, but I will do revision for your test. And I think if you look column, I show you. So if you look test compilation ni, sebelah kiri ni, you can see that you have a few SAM. And then I will try as a coordinator to put last year or last semester test as well lah. Alright, so then you can try and look. Okay, so I think for next week revision, you try do all these three, and then you can actually check lah, the answer scheme is there as well. Okay, but I will discuss the updated punya test SAM lepas. Okay, I'll get the question first and then share with you, and then you try do it, and next week we discuss about that. Okay, alright, any question?
Madam, saya tak jumpa submission report for assignment lah.
Okay. Sekarang kita tengok. Mungkin saya tak set lagi ke? Kejap. Wait still cari under saya. Kan? Under saya. And then assignment. Ada lah. Okay, kejap. I share the screen back. Ke takkan you tak nampak lagi? Kejap.
Okay, ada.
Alah, saja je. Okay, sini
Ada, tengok tak ada. Okay.
So ingat, seorang je submit, jangan semua orang submit. And then I selalu memang suruh tekan submit tau. Maksudnya kalau siapa yang kadang-kadang draft ni, you tak tekan submit lagi. I rasa quiz 2 pun ada seorang ke macam tu, I tak ingat. Tapi better you tekan submit, sebab bila I set tu, memang I akan minta student tekan button submit. Betul tak?
Betul.
Sebab setengah lecturer, once you upload je, dah consider submit. Tapi I nak you confirm, file tu, ya ke you nak submit yang tu? Macam tu. Alright? So, yeah. So, I think that's all good for today. Anything else? No? Yes? No? Yes?
No, Doctor, tak ada.
No. Okay, so again, manage your time wisely. Okay, if you have problem, try get help. And sometimes I know even you are at home, you don't have anyone to talk to, find someone to talk to. Okay, because sometimes kalau you stress sebenarnya, you kena bercakap sebenarnya. So, kadang-kadang dalam rumah, itu je you jumpa kan. So, you kena berbual. Telefon lah kawan you ke, siapa ke, okay. Nak WhatsApp, maksudnya nak tanya soalan lain pun boleh lah. Maksudnya applied step punya problem, you boleh tanya I ataupun tanya kawan-kawan you. Tapi isu-isu yang lain, stres-stres yang lain yang memang bukan formal ni, I harap you pandai manage juga. Okay, ada problem, cari bantuan. Okay, jangan senyap dan accept je, macam tu. Alright? So I think that's all. Okay. Have a nice weekdays lah. Alright. Itu je. Cuma untuk test, buat soalan dalam modul dah cukup. Tak perlu tengok benda-benda lain. Oh, I rasa I kena I kena warning kot you all ni. Issue check kan? You all semua mestilah tahu kan issue check tu. Jadi, kita lecturer memang ada penalty lah. Kalau kita nampak sama je dengan check, you memang sebenarnya akan dipotong markah. Okay? Kita mungkin tak bawa you sampai ke atas. Tak. Tapi kita orang buat macam tu, penalty terus. Alright? So, try your best. Confident with yourself. This is your own knowledge. Okay? This is a challenge for you lah as a student as well. And then to practice your ethic tu. Okay? Sebab ethic ni, kalau you tak practice daripada kecil pun, sampai besar nanti, sampai you dah jadi macam I pun, you boleh ke arah yang salah. Okay? Jadi, cuba practice ethic tu dari sekarang. Alright? Okay, so I think that's all for today. So, thank you class.
Thank you, Doktor.
Thank you, Doctor.
Thank you, Doctor.
Thank you, Doctor.
Thank you, Doktor.
Thank you, Doctor.
Thank you, Doctor.
Thank you, Doctor.
Doctor.
Thank you, Doctor.
Thank you, Doktor. Doktor,
Ya,
for untuk assignment yang question 7 tu, group saya ada hantar untuk check. Lepas tu doktor komen, doktor kata question 7 between group which is all male and all female.
kalau you tengok,
Maksudnya,
maksudnya kalau you tengok total female, kalau you total female dengan total male, kalau you tak divide daripada empat tu berapa? All male berapa? Ada berapa orang?
68.
Okay, 68. So, you pergi Excel balik, you cari descriptive statistic untuk 68 tu. Itu untuk female ke? Lepas tu cara buat untuk male juga. So,
Untuk
you akan
semua.
yes, semua. So, you akan compare mean female, mean female, mean male. And then variance, standard deviation dia. You compare dua group tu je. Tapi nilai dia consider nilai untuk semualah. Dia bukan nilai macam yang soalan nombor 8. Soalan nombor 8, kalau dia kata sample size, so dia kalau female small sample macam mana? Bigger sample macam mana? You compare yang tu. Tapi kalau untuk soalan 7 tu memang semualah.
Okay. Thank you, Doktor.
Okay, thank you.